Welcome back to my lecture on probability and statistics. In this section, we're going to be talking about sampling distributions, and first we're going to mention the central limit theorem. And the result of the central limit theorem states that, let's say I have some random variable. We're going to say it's 0, 1, 3. And these are the values we have for our random variable. We're going to call this our first sample. We're going to take another sample. This sample is going to be 1, 3, and then we're going to get 2, and then we're going to take a third sample, and we're going to get -1, 4, and a 2. Okay. So we have, this is going to give us an x bar 1, this is going to give us an x bar 2, and this is going to give us an x bar 3. We don't really need to calculate what these values are, but I just want to show that we have 3 different samples from the same population. So we have 3 samples from our sampling space in our first sample, 3 samples from our same sampling space in our second sample, and 3 samples from our third sample space, from our sample space for our third sample. I know I said the word sample a lot, but that's what's happening here. Okay. So the thing to understand is that we don't know how our sample space is distributed. Our sample space could look like this. We have no idea. No idea. But what the central limit theorem tells us is that our means, our sample means, all of them are going to be asymptotically, in limit, they're going to be asymptotically normally distributed, where the mean is going to be the true sampling mean. Actually, let's just call it mu. Our true sampling mean is going to be the center of our normal distribution, and our variance is going to be our population variance divided by our sample size. So every single one of these, so x1, and this is going to be an I here, excuse me. So the mean under our x1 here is going to be distributed asymptotically normal with the true population mean and our population variance divided by, excuse me, that should have been 3, because there's 3 in this sample. And it'll be the same for xn. It'll be asymptotically normal with center mean mu and sigma squared over n. And this is the central limit theorem.